In this video, we're going to talk about the graphs of the other four trigonometric functions: secant, cosecant, tangent, and cotangent. Now, if we know properties of the graph of the sine function and the cosine function, then automatically we should be able to figure out many of the properties of secant and cosecant, because we know that secant is just the reciprocal of cosine and cosecant is the reciprocal of sine. So to start with, if we're thinking about the fact that secant is the reciprocal of cos, then you know that wherever cos of x is 0, that secant of x is going to have vertical asymptotes, because you would have secant being 1 over 0 or undefined. You also know that the fraction 1 over something could never be equal to 0, because remember, when a fraction is equal to 0, the numerator is equal to 0, and here the numerator is always 1. So that means secant of x could never be 0, or in other words, could never cross the x-axis. And of course, since secant and cosine are reciprocals of each other, well, then wherever cos is positive, so is secant, and wherever cos is negative, so is secant. And you can come up with similar sorts of things to say about the other function, cosecant. The fact that it is the reciprocal of sine means it'll be positive whenever sine is positive and negative whenever sine is negative. Since cosecant is 1 over sine, cosecant could never cross the x-axis, since that numerator would never be 0. And since cosecant is 1 over sine, then wherever sine of x crosses the x-axis, that's where cosecant of x will have vertical asymptotes. And we can see that with my two graphs that I have here. First, I have the graph of the secant function on top of the cosine function done dotted in sort of a light gray. And so you'll notice that wherever the cosine function has a value of 1, secant is the reciprocal of that. Secant is also 1. Wherever cosine is negative 1, secant is the reciprocal of negative 1, which is also negative 1. And that as the cosine function gets closer and closer to 0, the secant function gets larger and larger and larger. And similarly for the cosecant graph, wherever sine is 1 or wherever sine is negative 1, that's where cosecant has that same value. Where sine is positive 1, for example at 90 degrees, cosecant is the reciprocal of 1, which is also 1. When sine is negative 1 at 270 degrees, or 3 pi over 2, that's where cosecant is also negative 1. And just as before, as the sine function gets closer and closer to the x-axis, the cosecant graph gets larger and larger and larger. Now, we've got a bunch of properties for the secant and cosecant functions, and again, most of this comes directly from the fact that secant and cosecant are reciprocals of cosine and sine. So we had, for example, for cosine, it crosses the x-axis at pi over 2 plus or minus, at 3 pi over 2 plus or minus, at 5 pi over 2 plus or minus. That's where the cos graph crosses the x-axis. And so those are places where secant has vertical asymptotes, which means that those are places excluded from the domain. Secant has infinitely many places that are removed from its domain because it has infinitely many vertical asymptotes. And here I've got the same information down here for the equations of the vertical asymptotes. At x is a positive pi over 2, at x is negative pi over 2, 3 pi over 2, negative 3 pi over 2, and so on. And of course, you've got similar things that you can be saying about cosecant, where the sine function crosses the x-axis at pi, at 2 pi, at 3 pi, and so on. At all of those places, those would be places where the sine function has an x-intercept, so those are all places where the cosecant graph would have vertical asymptotes, and those would all be places not in the domain of cosecant. We know that if we're thinking back to our graph, the only y-intercept that we have would be for the secant graph. Remember that since the cosine graph has the point 0, 1, then the secant graph should have the point 0 reciprocal of 1, which is 1. The sine graph doesn't have any y-intercept, and the reason it, the cosecant graph rather, doesn't have any y-intercept, and the reason it doesn't is because the sine graph crosses the x-axis at the origin, so the cosecant graph should have a vertical asymptote passing through the origin, vertical asymptote of x is equal to 0. Neither of the two graphs have x-intercepts, and we know, of course, the symmetry is the same. Since cosine is even, so is secant. Since sine is odd, so is cosecant. And both graphs have period of 2 pi because sine and cosine both have period of 2 pi. Now we could say similar sorts of things about tangent and cotangent with a little bit of extra work because, of course, tangent is the ratio of sine to cosine. Tangent of x is sine of x divided by cos of x. So since cos of x is in the denominator, then wherever cos of x is 0, that's where we'll have vertical asymptotes. Since sine of x is in the numerator, wherever sine of x is 0, that's where we'll cross the x-axis. So if you're thinking about facts for tangent, tangent should have the same x-intercepts that sine does, since whenever sine of x is 0, that will make tangent of x equal to 0. Wherever cos of x is 0, wherever cos of x has its x-intercepts, that's where tangent will have vertical asymptotes. And the one other fact that we might have noticed for the last little while was when we were calculating our exact values of trig functions at angles where the reference angle was 45, so at 45 degrees or at 135 degrees or at 225 degrees, at all of those places where the reference angle is 45 degrees, sine and cosine are root 2 over 2 or negative root 2 over 2, depending on which quadrant we're in, which means that sine divided by cos should either be 1 or negative 1 when we're at 45 or at 135 or at 225. At all of those angles that have reference angle of 45 degrees, that's where tangent would be either positive 1 or negative 1. And you can say similar sorts of things about cotangent because, of course, cotangent is cosine divided by sine. So in other words, wherever the cos graph has x-intercepts, that's where cotangent has x-intercepts. And since cotangent is cos divided by sine, wherever sine is equal to 0, that would be where the cotangent graph has vertical asymptotes. It also has the same 1s and negative 1s that the tangent graph does at 45 degrees or anything with a reference angle of 45 degrees. Either cos and sine will be identical or cos and sine will have opposite signs of each other, so cotangent would either be positive 1 or negative 1. And here's a couple of cycles of our tangent and cotangent graph. Remember that tangent and cotangent were the two exceptions to the period of the trig functions. All the other trig functions have a period of 2 pi, but for tangent and cotangent, they both have a period of only pi. That if we're looking at the tangent graph, for example, we can see that we've got vertical asymptotes at 90 or pi over 2. We have vertical asymptote at 3 pi over 2 or 270, at negative pi over 2, negative 90. Those are all places where the cosine graph would cross the x-axis, so those are all places where the tangent graph has a vertical asymptote. We can also see that tangent is crossing the x-axis at 0 and at pi, and it would cross again at 2 pi and 3 pi. Those are all places where the sine graph crosses its x-axis, and those are all places where the tangent graph crosses its x-axis. And you could say similar sorts of things about cotangent. That cotangent, again, also has a period of pi. It repeats itself every pi units. That wherever we've got our x-intercepts at pi over 2, at 3 pi over 2. Those are places where the cosine graph crosses the x-axis. Our asymptotes at 0, at pi, at 2 pi, those are places where the sine graph crosses the x-axis. Since cotangent is cos divided by sine, wherever sine is 0, cotangent is undefined. Cotangent would have a vertical asymptote. And so we've got all of our properties for our tangent and cotangent functions. I've got our domain listed for tangent and cotangent. For our domain, remember any place where we have a vertical asymptote is not in our domain, and that for tangent, that would be any place where cosine is 0. Since tangent is sine over cosine, wherever cosine is 0, in other words, the x-intercepts for cosine, those are places that tangent is undefined. Since cotangent is cos divided by sine, wherever the sine function is 0, that's where cotangent is undefined. Now, here's a nice little exception to the rule. Almost all the other trig functions that we saw had limited ranges. They were either defined between -1 and 1 for sine and cos, or cosecant and secant, it was everything larger than 1 or everything smaller than -1, nothing between -1 and 1. For the tangent and cotangent functions, those are defined where all the y values, the outputs, are all real numbers. Notice that all the positives and all the negative y values are on this graph for both the tangent graph and the cotangent graph. We have a y-intercept. For tangent, the y-intercept was 0, 0, and we had that, of course, because the sine graph has an x-intercept at 0, 0, and its y-intercept is also there. And since tangent has the same x-intercepts as sine, then it has that intercept 0, 0. Cotangent has a vertical asymptote at 0, so that's why we have no y-intercept. There's x equals 0 of vertical asymptote, so there is no y-intercept for the cotangent graph. And again, for the x-intercepts, for tangent, the x-intercepts happen whenever the sine graph crosses the x-axis, which is at 0 and 180 and 360 and all the rest. For the cotangent graph, that has x-intercepts whenever the cosine function crosses the x-axis, and that's at 90 and 270 and so on. Both functions are odd. Remember that the only even trig functions are the cosine function and the secant function, that all the other 4 trig functions are odd. The one nice thing you can be happy about is that for this class, you only need to know the basic facts for the tangent, cotangent, secant, and cosecant functions. I'm not requiring anybody to do any graphing via transformations, but of course, if you wanted to do graphing by transformations of these functions, you certainly could, just we're not requiring you for this course. One other thing to mention here is that the term amplitude really only applies to the sine and cosine graph, because for that there is a maximum value and a minimum value. So if you're wondering what's the amplitude of a secant graph or what's the amplitude of a tangent graph, the answer is we don't really talk about the amplitude of tangent or amplitude of secant because it doesn't really make sense, since that function doesn't have an absolute maximum value and an absolute minimum value. We can't really talk about what its largest and smallest values are.